All right, today we are going to do another Ansys Fluent simulation, but this time we are going to be simulating flow through a wind tunnel. So the first thing we're going to do, you're going to open Workbench, and you're going to choose Fluent, Flow, Fluent, and you're going to drag that over and then create a standalone system. I'm just going to go over what I have already done for the purpose of this video. Um, but for you, it'd be just create a new one. So first up, we go to Geometry. And then our wind tunnel are gonna be these dimensions. The way I did it is I used the rectangle tool to create a rectangle here. And then I extended lines out from the top and the bottom of the wind section, from the test section to fit this angle and this angle here from the horizontal of the top of the wind section, of the test section, I should say. Um, this angle and this angle approximate to about 24.5 degrees. And this angle and this angle approximate to about 5.01 degrees. I believe, yeah, 5.01 for this side, 24.45 on this side. Okay. And then you hit D to just hit delete these sections here. So that way it's just one solid piece. And then hit D on the keyboard, and it'll create this solid piece here. All right, and then you come back to Workbench, open up Mesh, and then it'll appear here. The way I did this mesh is I did right-click on Mesh, Insert Method, choose the entire geometry for the selection, and then used the triangle method. Hit Generate. And then to get this finer mesh, I changed the element size to 10 millimeters. And then once you do the mesh, it should look like this. And then the name selections. For the name selections, what you're going to want to do, come up to here to Edge. And then you're going to want to choose each end here and create a named selection. So you click on it, right click, create named selection. For this left side, I called it velocity inlet. For the right side, pressure outlet. And then for the top and bottom, I chose all 6 of these lines here. And to do that, you just hold Control as you're selecting to select multiple selections. And then create name selection, tunnel wall. All right, so once you do the mesh and name the selections, you can come over back to Workbench. You're going to right click, hit Update. And then you're going to want to come to Setup. Setup will open Fluent here. The first thing you want to do, come down to Models. The way I did this for turbulent flow is I did energy on, and then viscous standard, viscous K epsilon, standard model, enhanced wall treatment, and then turn pressure and thermal effects on. And from there, go down to materials, fluid, air, air density of 1.225 and a viscosity of 1 times 10 to the negative 5 is fine. You can close that. You come down to boundary conditions, double click on here, and it'll bring up here. You're going to want to come to velocity inlet, edit, All right. So for this assignment, you have to have a test section velocity of 15 meters per second. Um, if you calculate the area ratio, the contraction ratio for this piece here, this first part of the wind tunnel, and multiply that by the 15 meters per second you need for the test section, you need your inlet velocity to be 5.625 meters per second. Just make sure 5.625. Okay. Want to hit apply and close. The other things should be fine. Just for tunnel wall, make sure it is a stationary wall. So you come to tunnel wall, edit. Once it loads, just make sure it has stationary, no slip, apply, close. And then from there, you can come down to reference values, compute from the velocity inlet, and then just make sure all this stuff looks good. So density 1.225, that's fine. Make sure your inlet velocity is the same as the one you put in your boundary conditions. And then viscosity, all that's good. So you come down after that, you come down to initialization, go hybrid initialization, click initialize. It'll run its initialization down here in the console. And then once it's done, you come down to run calculation. For this one, I just ran 250 iterations. You shouldn't need much more than that, uh, just for the sake of computing power and time. So once you 250 calculate, and then it'll run. Now once it's done running, to get your plots, you just come down here under results, plots. Excuse me. Oh. All right, I'm sorry for the cut there. I had to restart my Ansys. It froze up on me for a second. So once you do the calculation, they say down here in the console, calculation complete. And then for the graphs, you can come down here to results, go under plots, XY plots. And then you can plot for what you need. So for this case, it'd be all four, or pressure, static pressure, save plot. This would be the pressure over the entire surface. For you can do dynamic pressure, do velocity, and that is an XY of velocity versus position over the entirety of the thing. For contours, go down here to graphics, contours. I have some already ready to go here. So you would just click on here. It'd give you this contour of velocity. You go over here, so compute and display, and then here's your velocity contour. So as you can see, the velocity increases to where you get to the test section where it's about 15 meters per second. And then it decreases at the end there. And then you can do the same thing for pressure. You just change it here. Pressure, compute display, all that good stuff. For the center line, for calculating the variation along the center line, you come down here to XY plot. You want to create the XY plot. And for here, you're going to create a new surface. You're going to create a line. And this is going to be your center line. So these points calculate from the origin of your geometry. So it calculates the points from this origin point. So wherever you create your geometry, your origin point is there. Since I created my origin point here at the start of the test section, I need my center line to go, I believe it was negative 1.1176 for the start point. That's correct. Negative 1.1176. And then for your x2 on the other side, it would be at 1.176 you see here, or 1.1176 you see there, plus your width of your test section, 1.2192, plus the width of your diffuser section, so 1.5748. So you want your x at 3.9116. And then remember, this is based off of your origin at your geometry point here. Now, since this is the bottom of the test section, I need my center line halfway up the test section. And for the parameters, the height of the test section is 0.6096. To half that, it would be, come back to Fluent here, 0.3048 for both y coordinates. Obviously, it's a 2D line, so there's no need for a z component. Create that. Hit close. All right, and to find your x along your center line here, or your velocity, hit center line, save plot. And it'll look like this along the center line. Do the same thing for pressure. You can do static pressure, dynamic pressure, that's pascals, and then total pressure. It'll look a little bit funky compared to the other pressures, but that's how it's supposed to look. As for the other, the vertical distribution of the velocity, dynamic, and total pressures, you're going to have to create another new line, and this is going to be at the center of your test section, again, relative to your origin point here. So for my vertical line here, it's going to be, uh, where is it? It's going to be this length, so 1.2192 over 2. So my x is going to be 0.6096. This is a vertical line, so there's no change in x. And then you're going to go from 0 to your top of your test section. Let's name this test section center. Okay. And then you just choose your test section. And to make it a vertical distribution, you just flip these. So plot direction, you have x0, y1. And it'll look like that. And do the same thing for velocity. And then, of course, do dynamic pressure and total pressure. And that is all. That's all I have for you today. All right, thank you.